If we have a system of two equations, x squared plus 3y equals 8x plus y equals 4, we have alternatives in what we could do. We could multiply the second equation by -3, then add the 2, that would eliminate y. But alternatively, we could solve for y and then plug that solution into this equation. And that's how we're usually going to do nonlinear equations. Okay, method of substitution. So we're going to use substitution. Solve, circle 2 means second equation. For y, we get y equals 4 minus x. And then we plug that into the first equation for y. Excuse me, and we get x squared plus 3 times 4 minus x equals 8. Well, this is going to be a very easy equation to solve. We recognize this as a quadratic equation. We simply multiply through by 3 here, subtract 8 from both sides, we get x squared. Look before I write, x squared minus 3x, then we'll have plus 12, and then we'll also have minus 8 when we bring this 8 over. We want to get this all equal to 0. And I'll write down the steps, plus 12 minus 8. So we have x squared minus 3x plus 4 equals 0. Now, we find that I didn't make a great selection of the equation because this equation is going to have complex number solutions. The discriminant is negative. 9 minus 16 is negative 7. But we might as well go ahead and solve this. Most of the equations you see, I think, are going to have real number solutions. I just made this up off the top of my head without really thinking about what might happen. Okay? Not always a good idea, but sometimes you get some interesting results. So we get I'm not going to write out all the steps. 3 plus or minus the square root of negative 7 divided by 2. So we get these two solutions. So now plug into the we'll plug into the second equation, because if we plug into the first equation, we're going to have to square these, which is not difficult, but it takes a little longer, it takes a little more writing. If we plug into the first equation, we just have the first power of x, we don't have to square them. So we get see if I can write that more clearly and correctly. We got 3 halves plus the square root of 7 over 2 times I plus y equals 4. And then we get 3/2 minus the square root of 7 over 2 times I plus y equals 4. And very easy to complete that solution. Y is going to be, first of all, you're going to have 4 minus 3/2. Well, that's 8/2 minus 3/2, that's 5/2. And I keep wanting to write a square root of 2 when I'm trying to write a square root of 7. Okay, so square root of 7 over 2 I. And this one gives you y equals 5/2 plus the square root of 7 over 2 I. So our solution set is there it is again. Can't seem to write a square root of 7. Keep writing a square root of 2. And I did it up here too. Let me fix it. We get 7 here. So right there is our solution set for this system. The steps are straightforward. Solve one of the equations for one of the variables, and then plug that result back into the other equation. Again, I didn't intend to get the complex solutions, but they're really no more difficult than real valued solutions.